The physical world and measurement concepts only. Second part. What do you mean by errors in measurement? Actually, errors in measurement means we'll be having a two value, that is actual value and the measured value. So the difference between these two, that is the actual value and the measured value, will be the error in measurement. So error in measurement is the value that is the difference between true value and the measured value. There will be different types of errors in measurement. That is, it can be a systematic error or a controllable error. It can be a random error and a gross error. Now, what do you mean by a systematic error or a controllable error? The error that can be caused due to a known causes. That is the systematic or controllable error. Since it is a known causes, that is the cause of the error is known, then it can be controlled or minimized. So it is known as a controllable error. And this error can be a positive or a negative. And these errors can be minimized when causes are known. Next is the random error. What do you mean by random errors? Random error means the causes are unknown. If the causes of the error is unknown, it cannot be a controlled or a minimized. For example, when the person repeats the same observation in the same condition, he may get different readings at different times. So it can be controlled or reduced by repeating the observation a large number of times and taking the arithmetic mean. And this arithmetic mean, the value that is getting by the arithmetic mean of different types of observations, will be closer to the most accurate reading. That is the random errors. Random errors are the unknown causes. Okay, the errors that is caused due to unknown causes, and it can be reduced by taking number of readings and taking the arithmetic mean of that reading. Now, what do you mean by gross errors? Gross errors means arise due to human carelessness and mistakes in reading instruments or calculating and recording the measurement results. Now, the systematic errors or controllable errors can be of different types. That is, it can cause due to the instrumental errors, environmental error, and observational error. What is instrumental error? Instrumental errors are due to imperfect design or enormous manufacture or misuse of measuring instrument, and it can be reduced by using more accurate instrument. Okay. Next is the environmental errors. Environmental errors are due to change in external environmental conditions such as temperature, pressure, humidity, dust, vibrations, etc. Now, what is an observational error? Observational errors arises due to improper setting of apparatus or carelessness in taking observations. Next of representation of error. How all can we represent the errors? First one is the absolute error. Absolute error means it is the difference in magnitude of true value and the measured value of a physical quantity. For example, let A bar be the true value and measured value be A1, A2, A3, etc. up to AN. Okay. So we get the true value by finding out the arithmetic mean of all observation. That is, observations are A1, A2, etc. up to AN divided by n number of observation will give the arithmetic mean, which is the nearly closer to the accurate value. Now, what is the absolute error? That is the delta A1 will be equal to arithmetic mean minus A1. That is the true value minus the measured value. A bar minus A1. Next, delta A2. That is absolute error in A2 will be equal to A bar minus A2. Similarly, up to absolute error at n observation. That is delta AN equals A bar minus AN. Next representation of error is the mean absolute error. Mean absolute error means it is the arithmetic mean of all absolute error in the measured value. That is delta A bar, the whole bar will be the mean absolute error. That will be equal to absolute errors arithmetic mean. That is delta A1 plus delta A2 plus delta A3 up to delta AN divided by n number of observation. Next representation of error is the relative error or fractional error. Relative error or fractional error means it is the ratio of mean absolute error to the mean value, that is the true value. That is relative error is equal to delta A bar whole bar by A bar. And finally, we can represent the relative error in percentage. That is the percentage error. Relative error multiplied with 100. Okay. Propagation of errors in mathematical operation. That is, it can be errors in sum or difference, errors in product or division, and errors in power of a quantity. Now in depth, that is the errors in sum or difference. Actually, it is a sum of absolute error in an individual quantity. For example, let question be x equal to a plus b or a minus b. Okay. So a and b are the individual quantity. So their absolute error will be represented as plus or minus delta A and plus or minus delta B. So the maximum absolute error will be delta x equal to delta A plus delta B. That is the sum of absolute error in individual quantity. Now what is the percentage error? That is delta x by the actual value, that is the x into 100. Now, in terms of absolute error, we can represent as x plus or minus delta x. And in terms of percentage, it can be represented as x plus or minus delta x by x. Next is the errors in product or division. That is actually, it is the maximum fractional or relative error in the product or division of quantity is equal to the sum of fractional or relative error in the individual quantity. So how can we represent the fractional error or a relative error of an individual quantity? That is, if x equal to a into b, that is, it represents the product, and a by b, it represents the division of two individual quantity, that is a and b. Now what is the fractional error? That is delta x by the actual value x. That is equal to plus or minus delta a by a plus delta b by b. Now next is the errors in power of a quantity. That is the maximum fractional error in a quantity raised to a power n is n times the fractional error in the quantity itself. That is, if the question is x is equal to a raised to n, where n is the power unit, then its fractional error, that is the delta x by the actual value x, will be equal to the power, that is the n, into fractional error, that is delta a by a. In general cases, when x is equal to a raised to p, b raised to q, c raised to r. Similarly, x is equal to a raised to p, b raised to q divided by c raised to r. In both the cases, the answer will be, that is the fractional error will be delta x by x will be equal to the bracket of power, that is the p, into fractional error, that is delta a by a, plus power of b, that is q, into fractional error delta b by b, plus power of r, c, that is r, into delta c by c. Now what is the least count? Least count, actually it is the smallest value of a physical quantity that can be measured with an instrument. ഒരു ഇൻസ്ട്രുമെന്റ് കൊണ്ട് തന്നെ നമുക്ക് ആ ക്വാണ്ടിറ്റിയുടെ ചെറിയ വാല്യൂ മെഷർ ചെയ്യാൻ പറ്റുമെന്നുണ്ടെങ്കിൽ നമ്മൾ അതിനെ വിളിക്കുന്നതാണ് ലീസ്റ്റ് കൗണ്ട്. And here two instruments are being introduced, that is vernier caliper and the screw gauge. Vernier calipers-ന് രണ്ട് സ്കെയിൽ ഉണ്ട്, മെയിൻ സ്കെയിൽ, വെർണിയർ സ്കെയിൽ. അപ്പൊ അതിന് ഓട്ടോമാറ്റിക്കലി മെയിൻ സ്കെയിൽ ഡിവിഷനും വെർണിയർ സ്കെയിൽ ഡിവിഷനും കാണും. സോ that is if suppose the size of one main scale division, that is the MSD, is m, and That of one vernier scale division is V unit. Along with that, length of A main scale division is equal to the length of B vernier scale division. Then AM will be equal to B into V. That is, A is the main scale division and into the main scale division capital M will be equal to the B vernier scale division into vernier scale division unit. That is the B. It can be also be written as V is equal to A by B into M. On subtracting both sides with M, that is M minus B is equal to M minus A by B into M, we get the answer as M minus V will be equal to B minus A by B into M, where the quantity M minus V, that is the left hand side, M minus V is called the vernier constant, and on the right hand side, that is B minus A by B into M is called the least count of vernier caliper. Now next instrument is the screw gauge, where screw gauge consists of a pitch scale and a circular scale, and least count will be equal to pitch by number of division on circular scale. Okay, thank you.